NPR. Anybody need whiteout? No whiteout? Okay, so I'm gonna write down below it, this means that there are n choices, like to choose from, and R is how many you want. So this one up here would have been 10 permutation 4, because there were 10 choices of digits we could have had. It's a permutation because we care about their order, and 4 is how many digits we want. That making sense to you? And then the formula, so n is the first one, so I'm going to write n factorial on top. On the bottom, anybody think of this? How do you go from, if this is n and this is r, how do I get to 6? So I'm going to write in parentheses n minus r factorial. Okay. So a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can a subject pick a first, second, and third activity? We're going to do this in many different ways, okay? All right. First, second, third activity. They've got 8 activities. So they've got 8 activities for their first choice, and then 7, and then 6. It's an easy thing to type in our calculator, which again, you're thinking right now, why would we do it any other way besides 8 times 7 times 6 in our calculator, which is 336. But I'm just doing this to show you all the different ways you can do it. Now, let's talk about why order matters for this. Because it says, how many ways can they pick a first, second, and third activity? So they actually care about what you do first, what you do second, and what you do third. Like, you could have picked the exact same activities, but if they were in a different order, they would still count in this 336. It's not about picking which activities, it's what order the activities are in, okay? Same thing here. With the 4-digit code up here, like, imagine that you have a 4-digit code. Let's say your code is 0158, okay? And that's the code to get into your house. It's not like if you go up to your house and you type in 5081, you'll still get in because you got the right numbers. You have to have them in order. That's what a permutation is. The order matters, okay? Okay, now other ways you can do it in your calculator, and we're going to try all of them, is doing 8 factorial divided by what?
3.
Oh, it's 8 minus 3, which is 5 factorial. Because you kind of have to imagine that there's this big factorial on top, times 5, times 4, times 3, times 2, times 1, and then we're dividing out the 5, 4, 3, 2, 1. So that's why it's subtraction. So in your calculator right now, try 8 factorial divided by 5 factorial. Hello there, Noah.
Morning.
Okay. You're going to want a calculator too. Which should also get you 336. And then the final way is something, there's actually a permutation key in your calculator. So everybody type in 8 into your calculator right now. And then go to math, probability. Do you see the NPR? Click that one. And then on the other side of it, you're gonna write 3, NP3, like that. So, you can always, in this class, if you're not going on to AP Stats, but 2 of you are either of you taking AP Stats? I don't remember.
I don't think so.
Okay. So Nathan and Noah, this formula comes up a lot, so you have to understand it. But for everybody else, if you're just doing this in your calculator, that'll be good enough for the test and all that stuff. Okay, next, 43 race cars started the 2013 Dayton 500. How many different ways can they finish first, second, and third? All right, try that with your group, please. I'll be your group, Noah.
So there should be 3. Should be 43 coming.
And I'll give you the top half of the sheet in just a little bit. (43) permutation 3. Did you guys get 74,046 ways?
Yeah.
Isn't that nuts? That's how many just ways that just the first 3 people, the first 3. Now, if I tried 43 factorial in my calculator right now, (6.04) to the power of 50, or not power, but moving the decimal 52 times. That's how many different ways they could finish. I know. It really starts to blow your mind once you start thinking about all the different ways this stuff can happen. All right, on the back side. A building contractor is planning to develop a subdivision. The subdivision is going to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. In how many distinguishable ways can the houses be arranged? Okay, so what they're talking about is, let's show one way that they can be arranged. So we got I'm gonna start drawing pictures. So we got some one-story houses, and then maybe we got a 2-story house thrown in, and then I'm gonna call this a split-level house. And then what, we got maybe another one, another tall one, little one, another split, another one, and another tall one. So I've got 6 one-story houses in my picture. I've got 4 two-story houses in my picture, and I've got 2 split levels. So order does matter in the fact that 3 little ones come first, but there's no distinguishable way to notice the difference between the 3 little ones. So basically what they're saying is that instead of it being this factorial, that some of them are kind of repeats, so they don't really count. We don't really know how that's going to work out. So here's how you do it. First of all, you add them all up. 6 times 4 plus 2 is 12 factorial on top. That's what we would normally have. And then you divide